Hello dear student, in a previous lecture we had done so many example of Charpit methods. Now today we are going to discuss some special types of first order P.D.E by Charpit method. So the first one is equation which is involving P and Q only, that is the partial derivative P and Q. So the function may be f of pq is equal to 0. Therefore, this equation does not involving x, y and z. Z is a dependent variable. Therefore, this first derivative with respect to x is also 0, with respect to y is also 0, and with respect to z it's also be 0. So the Charpit equation, or you can say auxiliary equation, is minus dx by fp is equal to dy by minus fq is equals to dz by minus p into fp plus q. Fq is equal to dp by fx plus pfz is equals to dq by fy plus q fz. So here partial respect to x, y and z of f is 0. So put x, fx 0, fz, fy and fz 0. So ultimately we get dp by 0 is equal to dq by 0. So let's compare this both fraction. So dp by 0 is equals to dq by 0. This implies that this dp equals to 0, and we integrating both the side, we get p equal to something constant c, and putting this value p equals to c in our this equation number 1, we get q is also a function of c. So the complete integral is nothing but dz p dx plus q dy. So dz is as it is, p is nothing but something constant c dx plus q is a function of c with dy. So now integrating both the side, we get z is equals to cx plus phi of c into y plus something constant, you can say d. So this is our required complete integral, in which this p and q only. Let's see the example, that is p into q is equal to 1. So here you can see that this is a function in which is not involving only p and q. Therefore, by this result we can say that p equals to c. So let p equal to c. So put p equals to c in this equation. So c into q is equal to 1. Therefore, q equal to 1 over c. So the complete integral, is dz equal to p dx plus q dy. Dz is as it is, p is nothing but c dx plus q is 1 over c dy. Now integrating both the side, we get z is equal to cx plus 1 over c y plus something constant c. So which is our required complete integral of the given first order P.D.E. Another example is p plus q is equals to pq. This is for your homework. Try yourself. Now the second special types is equation which is involving just only independent variable, that is x and y only. That is the first order P.D.E is it of the form zpq is equal to 0. So ultimately its partial derivative with respect to x is 0, and similarly its partial derivative with respect to y is also 0. So the Charpit equation, so put this is our required Charpit equation, or you can say auxiliary equation. So put fx equals to 0 and fy equals to 0. So the Charpit equation is minus dx by fp is equals to minus dy by fq is equals to dz by minus p fp plus q fq is equal to dp by fx is 0, so we get p fz plus is equal to dq by fy is 0, q fz. Now I am comparing last two fractions. So ultimately this dp by pfz is equals to dq by qfz. So this fz is cancel out. So ultimately we get dp by p, dq by q. So integrating both the side, we get log p is equals to log q plus something constant log c. So log p is equals to log ac qc. Therefore p is of the form qc, and putting this p equals to qc in our first order PDE, we get the value of q, and for a complete integral we use dz equals to pdx plus q dy. So let's see by its example. So here example is p square minus q square is equals to z. So here you can say that this first order PDE is not involving the independent variable x and y. So therefore the solution is p equal to qc. So p equal to qc. So put p equals to qc in this equation. So we get q square c square minus q square is equals to z. So taking q square as a common out, we get c square minus 1 is equals to z. Therefore q square is equals to z over c square minus 1. So ultimately this q equal to under root z over c square minus 1. So q equals to z over under root c square minus 1, and p is qc. So therefore p equal to c under root z over c square minus 1. So the complete integral. So the complete integral is dz equals to pdx plus q dy. So dz is as it is, p is nothing but c under root z over c square minus 1 dx plus q is z under root c square minus 1 dy. So by integrating this term, we will get our solution. So this term can be written as c equal to c over under root c square minus 1 under root z dx plus 1 over under root c square minus 1 into root z dy. Divide both the side by root z. So we get 1 over root z dz is equals to c over under root c square minus 1 dx plus 1 over under root c square minus 1 dy. Now integrating both the side, we get our solution. So now integrating both the side, what we get under root z is nothing but z to the power minus 1 by 2 plus 1 over minus 1 by 2 plus 1 is equal to cx into c square minus 1 plus y over under root c square minus 1 plus something constant, you can say d. So z raised to minus 1 by 2 plus 1, so it is nothing but root z minus 1 by 2 plus 1 is 1 by 2. So it's 2 root z is equals to cx by under root c square minus 1 plus y over under root c square minus 1 plus something constant d. So which is our required complete integral of given first order PDE, that is p square minus q square is equal to z. And another example is p square into z square plus q square is equal to 1. So this is for your homework. So the third special types of first order Charpit method is separable equation. So in a separable equation, the equation can be converted in this form: f of xp, that is function of xp, is equals to function of yp. That is, a first order given PD can be converted in this form. So the ultimately in a separable equation, the dependent variable is absent. That is, the z is absent here. You can see. So ultimately the function is a function of the first order PD is a function of x, y, pq. So this is of the form f of xp minus z of yq is equal to 0. So ultimately the Charpit equation is dx by minus fp is equals to dy by minus fq is equals to dz by minus pfp plus qfq is equals to dp by fx plus pfz is equals to dq by fy plus qfz. So here we want partial derivative of f with respect to p, q, x, y and z. So fp, so we have to partial derivative to this function. So ultimately we get fp from here, and this is 0. So fp is nothing but small fp, capital Fq is nothing but this term is 0, minus is here, and derivative of g is nothing but gq. Similarly, fx is equals to fx, fy equals to minus gy, and fz, z is absent here, therefore this fz is a 0. So the Charpit equation, so put all these values in the Charpit equation. So fp is nothing but small fp is equals to dy by fq is minus gq, so it's gq, sorry. So it's dy by gq is equals to dz by pfp. Fp is small fp and fq is a minus gq, so it's gq, sorry. So ultimately this minus is minus and minus minus is plus, is equals to dp by fx is fx, fz is 0. Similarly is equal to dq by minus fy is minus gy. So this is equal to 0. Now here I am comparing the first and fourth fraction. So dx by minus fp is equals to dp by fx. So solving this equation, we get this relation is of the form f of xp is equals to c, and again this equation is fp equal to c and g yq is equal to c. So ultimately we get the function of xp is equal to something constant, and similarly function of yq is equal to something constant c, and again solving this equation for p and q, we will get our complete integral. So let's see by the example. So here the first example is p square into y into 1 plus x square is equals to qx square. So here you can see that the dependent variable z is absent. So we can convert this equation in this form, that is function of one side is function of x and p and another side is a function of y and q. So here you can say if I am dividing by y both the sides, so we get p square into 1 plus x square is equals to q x square is equal to y. So this is equal to something constant c by this relation. So this is equal to something constant c. So therefore p square 1 plus x square is equal to c. Therefore p square is equal to c over 1 plus x square. So by taking square root both the sides, we equal to p equal to c over under root 1 plus x square. And similarly for q, so qx square over y is equals to c. Therefore q equal to, sorry, here we have to divide by x square by convert from this equation. So it's my mistake, I am dividing here x square. So it's qy. So it's p nothing but cx square, and taking square root with cx. That's it. And qy equals to c. So q equal to cy. That's it. Okay. Q equal to cy. So the complete integral So the complete integral is dz equal to p dx plus q dy. So dz is as it is. P is nothing but cx over under root 1 plus x square dx plus q is cy d. So now integrating both the side, we get z is equals to integrating this term c into x over under root 1 plus x square dx plus c, integrating of y is nothing but y square by 2 plus something constant, you can say b. And here you can see the derivative of this numerator term is nothing but in a numerator. So for that equation, that integral, for that equation number 2, so integral x into 1 plus x square dx. So let 1 plus x square is equal to t. So we get 2x dx is equal to dt. So ultimately x dx is of the form dt by 2. So put all this value in this equation. So integral x dx is nothing but dt by 2. And this term is nothing but under root t. So this is equal to 1 by 2 under root t is t to the power minus 1 half plus 1 over minus 1 half plus 1. So this is equal to under root t. So therefore the equation root t is nothing but under root 1 plus x square. So the equation 2 becomes z equal to c into under root 1 plus x square plus cy square by 2 plus b. So which is our required complete integral. Right? Now let's see the another example, that is yp is equals to 2xy plus log q. So this yp equation is yp equal to 2xy plus log q. So here you can say it's log q. So here you can see that this is a separable equation which is not equaling the dependent variable z, and we can separate the equation in a function of f, x and p and y and q. So for this yp is equal to 2xy is equals to log q. So taking y as a common out, we get y into p minus 2xy is equal to log q. So divide y, so we get p minus 2x is equals to log q by y. So this is a function of p and x, and this is function of q and y. So take this is equal to something constant c. Therefore p equal to c plus 2x and log q is equals to cy. So q equal to e to the power cy. So the complete integral is dz equal to p.dx plus q dy. So dz as it is, p is nothing but c plus 2x dx plus q is e to the power cy dy. So negating both the side, z equals to cx plus x square plus e to the power cy into divide by c plus something constant d. So which is our required complete solution of given first order P.D.E. Now the fourth special type is Clairaut equation. So first order partial derivative, it is of the form z equals to px plus qy plus function of p and q, then this equation is known as a Clairaut equation. So here you can see that the first order PDE, it is of the form function of x, y, z. PQ is equals to px plus qy plus function of pq minus z. So for a Clairaut equation, for a Charpit equation, we want derivative with respect to p, q, x, y, and z. So the derivative with respect to p is nothing but it's x, and this term is 0. Here is from fp and is 0. Similarly for fq, so if this term is 0, from this we get y, from this we get fq, and z is 0. Fx, so partial derivative to x, so from p and remaining term is 0. Fy, this term is 0, this term is q, and the remaining also 0. And fz, so this all is 0 and z is nothing but minus 1. So the Charpit equation is minus dx by fp is equals to minus dy by fq is equals to minus dz by pfq plus pfp plus qfq is equal to dp by fx plus p fz equals to dq by fy plus q fz. So put all this value in this Charpit equation, or you can say Charpit auxiliary equation. So therefore minus dx by fp, fp is nothing but x plus fp is equals to minus dy by fq, fq is nothing but y plus fq is equals to minus dz by p into fp, fp is x plus fp plus q, fq, fq is y plus fq is equals to dp by fx, fx is p plus p, fz is minus 1. So p plus p minus 1 is equals to dq by fy, fy is q, fy is q plus q into fz, fz is minus 1. So from this we get minus dx by x plus fp is equals to minus dy by y plus fq is equals to minus dz by px plus pfp plus qy plus qfq is equals to dp by 0 is equals to dq by 0. So comparing last two fractions, we get dp by 0 is equals to dq by 0. So solving this equation, we get p equal to something constant a and q is equal to something constant b. So put this value in this equation number 1. So we get our complete solution, that is z is equal to px plus qy plus f of p, function of p and q, that is function of ab. So this is our required complete integral. Let's see the example, that is p plus q into z minus xp minus yq equal to 1. So for a Clairaut equation, we have to convert this equation in this standard form. So for this, I am dividing both the side by p plus q. So we get z minus xp minus yq is equals to 1 over p plus q. Therefore z equals to xp plus yq plus 1 over pq. So here you can see that this is nothing but Clairaut equation, that is function of z equals to px plus qy plus function of p and q. Therefore the complete integral is z equal to xp plus yq. Here we have to p equal to a, put p equal to a and q equal to b. So xa plus yb is equals to 1 over a plus b. So this is our required complete integral of a first order P.D.E. That is the given. Let's see the another example, that is PQZ is equal to P square into x plus q plus p square plus q square into fp plus q square. So first of all we have to convert in a standard lateral equation. So I am dividing both the side by pq. So we get pz equal to 1 over pq into p square over x cube plus p square plus q square over pq into yp plus q square plus 1 over pq. So therefore this z equal to this p term is cancelled out, so it's p by q into x cube plus p square plus this q term is cancelled out, so q by p is equal to yp plus q square plus 1 over pq. So therefore this z equal to, multiply this p by q in this bracket, so we get this q is cancelled out, is px plus p cubed by q plus, similarly for here, so we get pp is cancelled out, it's y cube plus q cubed by p plus 1 over p cube. So therefore this z equal to px plus y cube plus p cube by q plus q cubed by p plus 1 over p cube. So which is nothing but Clairaut equation, that is z plus px plus y cube plus function of x and y. So it's a complete integral. So just we have to put p equal to a and q equal to something constant b. Therefore this complete integral is z equal to xa plus yb plus a cube b plus b cube by a plus 1 over ab. So which is our required complete integral of first order P.D.E. that is the given.